Friday, I really think the most important exercises are from chapter 13, 13D. That means that you have to be able to solve using exponential equations or at least the algebra. And then you also got 13E. Those are the two main ones for algebra. Sketching wise, you guys would have picked up by now with transformation. So I'm not so particular with 13G and H and onwards, but 13D, 13E will determine how well chapter 13 is going to go. Okay, so you're really going to learn those algebra there, which checked your homework from last week. You should have done A, B, C. There are a few students who I didn't get to see, so therefore I put a 0 on there until you come see me, and then I'll put a mark for it. But yes, D and E is the aim for this Friday, at least. If you're trying to keep up with methods, then do some work. D and E will allow you to do chapter 13. Yes, Will, you had a question?
It's true Friday.
Yep. Okay, here we go. 13F. Let's begin with today's exercise. Now, I want you to copy this down. We're going to talk about logarithms and its properties. Will, talk again, I'll move you to the front. All right, here we go. We got y equals log e of x. Now, very similar to your exponential, you have some properties that are exactly the same, except it's in the inverse now. So this is your base, this is your current base, you've got a base e, so log with a base e, and your variable is x. This is your current graph that it looks like, that's your log e graph. Okay, so when you type in log e of x, this is your basic graph. Now obviously it changes based on whether you increase the base to be a 2, whether it's a 3, whether it's 4, it changes the shape of the graph. Now what I want you to pay attention to is with the logarithmic graph, it's very similar to your exponential. See, exponential, which you had a graph that would cross through 1 and it goes up, and you have an asymptote at y equals 0. Okay, it means that the graph will never reach 0 because you can always make it smaller and smaller, and it will exponentially grow in terms of height. Okay, so that's your e of x graph, where you can have 2 to the power of x, 3 to the power of x. This is what the graph will look like. When you do the inverse will switch everything. So if you think about your y-intercept right now, it's at 0, 1. See, at 0, 1, when you do the inverse, you're actually swapping the x and y axes, or x and y values. So you notice with the logarithmic graph now, 0, 1 was the y-intercept, now it becomes the x-intercept at 1, 0. So instead of 0, 1, it now becomes 1, 0. Instead of having the y-axis as your asymptote, y equals 0, it is now at x equals 0. So it never approaches the x-axis. I mean the y-axis, it never touches that. So here it never touches the x-axis for exponential. For logarithmic, it will never touch the y-axis. Everything gets flipped. Okay, if you think about it, it's a mirrored image. If you tilt your head, it's a mirrored image along the y equals x. Because you're saying that whatever y is, it now is equal to x. So if I draw a mirror image for you to see, it should be symmetrical along that line there. Okay, so along this line that I'm drawing, they should be symmetrical. That was 0, 1. This point here now is 1, 0. Okay, so right here, this point right here is 1, 0. They all switch. Instead of y equals 0 as your asymptote, it is now at, I'm going to do it in green so you can see, is your green at x equals 0. Okay? So I'm just going to write down the two properties that you got. You got x asymptote at, or vertical asymptote at x equals 0, and you got an x-axis intercept at 1, 0. Now why am I drawing the graph and getting you to analyze it? Because in 13G, that's when you analyze this, but I'm showing it to you early because I want you to see something. Very similar to exponential, when you increase the x values, it naturally gets larger, right? When you decrease the x values in the negative region, it gets smaller. Now what I want you to see is, when you do log e of x, right, you can see that after 1, log e of anything after 1, so that's where x equals 1, If you choose x equals 2, x equals 3, the y values are getting larger, right? But if you choose any numbers between 0 and 1, so like a half or a third, the y values are negative. And why is this important is because in this exercise 13F, your job is to recognize that when you do log e or 2, log base of anything, of a decimal number, 0.3 for example, the answer has to be negative. Okay? And that's one of the things that most students will overlook. And it's more important when you're doing inequations. When you have a negative, when you divide or times a negative, the inequations switch. Okay? And that's why it's important to recognize that log e of 0.3 has to be a negative answer, because 0.3 has to be somewhere here. It's about a third. A third, if you look at it, it's got a negative y value on the graph. Okay, so that's why any number between 0 and 1, if you do log e of any number between 0 and 1, it should end up being a negative number. Okay? And you'll be using your CAS to do that, to find out the answers there. But that's just one thing to pay attention to. That's why I'm mentioning that. So when you're doing your exam questions, for example, one of the things that you should also know is it is impossible to do log e of negative 2, for example. Can someone explain to me why, based on the graph? Why can't I do log e of negative 2? Because
the product of something can't be negative, right?
Very good. Because if you actually really think about exponentials, if you change this to an exponential, this is really saying e to the power of what? So I'll write it down. E to the power of what gives you negative 2. Now, if e is confusing to you, I can write 2. I can say 2 to the power of what give you negative 2. And we already know from our exponentials, you'll never have a negative value. Anything to the power of anything will never give you a negative answer. You can have 2 to the power of negative 1, that's a half. 2 to the power of negative 2 is a quarter. 2 to the power of negative 3 is 1/8. You will never get a negative value. So because you never get a negative value, the same thing with logarithms, you never get an x value. That's why the graph is on the right-hand side. There's no left-hand side here. Okay, on the left-hand side, if you did try to do log of negative 1, it doesn't exist. So we can't. Because essentially, you're really just saying e to the power of what gives you negative 2. And there is no answer that you can do to the power of to get a negative 2. Okay, so those are just the little properties to look at. So not only are you learning your algebra, when you're solving it, just be careful. There are certain equations where there is no solution to it, and you're meant to pick up on that. Just like when I say square root of negative 2, you're meant to pick up on that and say, well, you can't. You can't square root of negative 2. Okay, that's where exercise 13F lends itself in. That when you're solving for it, you're meant to know there are some answers that you won't get a solution, and there's some answers that are negative. And you only know that by paying attention to some of the details of logarithmic graphs. Okay? Now, let's move away from the graph because we'll do that tomorrow's session for 13G and analyze more of the graphs and transformations and sketch it. Today's lesson is still moving back to what you did in 13E. Using all your log rules, there are 5 log rules if you remember. There are 5 log rules, and in this case here, you'll be using a CAS, but what are you going to type to solve? Okay, and I'm going to show you the basics, what we've done for 13E, and you're going to do the same for this one. And then we're going to use our understanding to do inequations, and that's it for 13F. Okay, that's all I want you to pick up. Okay, and if you haven't started on 13E yet, the next page, I want you to start on question 5 to really practice all your 5 rules. Okay, so I said your homework for this up until Friday, I'm really checking 13D, 13E. That is very important. Without those, there's no point learning the graphs because you can't sketch them. Okay, so that's our goal today. Let's go back to 13F. Here we go. Let's do A. I'm going to do A so you can copy this one down. Just get used to the algebra and then type in your CAS to get your 2 decimal places, yeah? So here we go. A, we got 2 to the power of x equals 7. Now, why is this different to what you've done in 13D, for example? 13D was exponentials and you were solving by comparison. I'll give you an example of 13D. You would have had something like this. 2 to the power of x equals to 2 to the power of 3, right? Now, with this particular problem, x will have to equal to what? 3. Okay, because we're saying the bases are the same, the equations are the same, therefore the powers have to be the same. So therefore, x has to equal to 3. What's the issue on this side here with today's exercise? What's the problem, Sydney? Yeah, and we can't compare it because the bases are different. Unlike the first one, at least we can say, oh, since these two are the same, the bases are the same, therefore the powers have to be the same. But you can't do it over here because that's base 2, that's a base 7. Now in 13D, you learned to break down the bases as well. Sometimes it was 32, you were able to break it down, but you can't break a 7 down anymore. 7 is the smallest value you can get. It's a prime number already. So, how do we solve this? And it's just like what I tried to describe to you in 13E. You're doing inverses. Your goal is to undo base 2 to the power of. Now what do we say in 13E? What's the opposite or what's the inverse of base 2 to the power of? What's the operation? What's the inverse of an exponential? Logarithm. So this is what we're going to do. We're going to say, just like your mathematics that you've done since year 7, you balance the equation. If it's times 2, divide 2 on both sides. If it's add 2, you subtract 2 on both sides, right? Then this is an exponential base 2. Then what I'll be writing, and I'm going to do it in blue so you can see, I'll be doing log of both sides. So I'm logging both sides, okay? I'm going to write down the values again so you can see. It's still 2 to the power of x on the left, and it's still 7 on the right. So all I've done is I've just said, let's do the inverse of an exponential, which is to the power of. I'll do log. But log of what? See, this is a base 2, so then I should be doing log base 2. Because then therefore, I'm writing it down here. I'm going to say, well, since it's base 2, that's base 2, that's base 2. These two, log 2 of 2, are inverses. They're meant to cancel out. It's another way of thinking about it is like if I did exponential base 2, the inverse of that was logarithmic base 2. So I go backwards. It's like saying add 2, take away 2, times 2, divide 2. Exponential base 2, logarithmic base 2. It just looks different, but the techniques are the same. See, what you normally would have done is you would have done to both sides, add both sides, and they cancel out. Well, in this case here, log 2 of base 2 cancel out. So what are you left with on the left-hand side? Just x. Okay, so we're just left with x, and so x is equal to log base 2 of 7. And that's what you'll be typing in your calculator. And they'll solve that to 2 decimal places. But what I'm trying to emphasize for you to see is what you've done in year 7 is exactly the same. I'll show you an example you did in year 7. Okay, so you have x, and I say add 2 equals 8. In year 7 you came in and we taught you algebra, and instead of guessing the number was 6, you had to learn the inverse operations. You learned the order, and you figured out, well, what's the opposite of adding 2? And you would have said? Yeah, the answer is 6, but you would do? Subtraction, because this is adding 2, opposite of adding, or the inverse of adding. You would have said take away 2. So that's what I'm doing. I was like, take away 2, take away 2. So how it's a very similar process of what you're doing over here. So it's the same equation. I want to undo the base 2, so I did logarithmic base 2 on both sides. Just like this one, when you wanted to get rid of plus 2, the opposite of plus was take away. Take away how much? That's 2, so that's 2. And I've done it to both sides. And then what you'd say here is plus 2 take away 2 cancels out to 0, and what are you left with? X is equal to 6. And I've done exactly the same steps. If you think about the number of steps I've done from this step to this step, it's the same thing. The only reason why logarithmic and exponentials look hard is because you don't have a symbol. So you're used to seeing plus, minus. And then when you look here, there's no symbol. It's just a 2. But there is a symbol. It's the positioning is the symbol. And the log, instead of putting a symbol, they've used LOG. Okay, that's your symbol. So that's the symbol 2. That's the symbol 2. Okay, just like you did here, symbol 2. We're just doing the inverses. Okay, so if you type in your calculator right now, x will equal to log 2 of 7, correct to 2 decimal places, that's how you solve. And it's going to be the same for every one of these problems down here. Okay? And that's why I'm trying to get through to your head that logarithms is exactly the same as add, subtract, multiply, divide. You haven't done anything different since year 7. It's just a different way of looking at it. Okay, but the same techniques. All right, let's do another one. I'll do, let's do B down here, then I'll do C, so you can see the pattern's exactly the same. Here we go, we've got B, 3 to the power of x minus 1 equals 10. My goal is to find out x. I need to remove base 3. So how do I remove base 3? What do? I do? Yeah, log base 3. I'm going to log base 3 on both sides. So here we go. We're going to do exactly the same thing that we did in year 7. We're going to log both sides, log base 3 on both sides. So log base 3 of both sides. And on my right-hand side, I had a 10. My left-hand side, I have 3 to the power of x minus 1. Now we know because we're doing log 3 of 3, the inverses should cancel out. So I'm left with x minus 1 is equal to log base 3 of 10. But I haven't finished because I'm trying to solve for x. I'm not trying to solve for x minus 1, so I need to remove the minus 1. Opposite of minusing 1? Adding 1. So I'm going to add 1 on both sides. See, all I'm doing is just inverse operations here. I'm going to do it in blue again. So we're going to do in blue, we're going to add 1 on both sides. So add 1, add 1. Negative 1 plus 1 will cancel out. And I'm left with x is equal to log 3 of 10 plus 1, whatever that is on your calculator. But you can see I'm just following the exact same algebra techniques you learned since year 7. It's the same thing. We're just undoing the problem. Okay? Now, why I said C is going to be a bit tricky because remember there's a decimal point. So let's try this again. 0.2 to the power of x plus 1 equals to 0.6. Same drill. Nothing different. You've now got a base of 0.2. I want to remove base of 0.2. How do I do that? Yeah. Logarithms of base. Log base 0.2. Okay, so here we go. We're going to do the same things. We're going to do log base of 0.2 of 0.2 to the power of x plus 1 is equal to log base of 0.2 of 0.6. Okay? And then from here, same things. These will remove, and you got x plus 1 is equal to log of 0.2 of 0.6. And then remember to remove the plus 1, so we minus 1 on both sides, and x equals to log of 0.2 of 0.6 minus 1. Bam. Is that easy? Okay, so today's lesson, like I said, it's nothing tricky. Nothing is tricky about it. It's the same skill that you're just undoing the problem. Okay? And it's nice nowadays that your calculator can do log of 0.2 and 0.6. Back in my time, we could only do base E and base 10. Okay, we didn't have the ability to do log base 2 of 3. We had to learn an extra technique, which I'll teach you later down the track. But on our calculators, we couldn't write this. So if you wanted to find out log base 3 of 10, we had to do it another way. Because we only had log 10.
Log by hand.
No. You can, but that was even before my time. So my teachers who taught me at the time, they had a logarithmic table. So if you wanted to find an answer, there was already someone who's calculated the table for the general numbers. Right. And then if you wanted to look for it, you'd have to go through, base 3, 0.6, and you look at the value, and you work with that. And my time, I already didn't have a table. I already had E's and 10s. That's why in your CAS or your normal calculators, if you look at it, it'll say ln, it'll say log. So if you look at the calculators, there's ln and log 10. Okay? The reason why, on your scientific calculators as well, these are your two basic ones. ln is actually log base E. What it means is logarithmic natural number. E is the natural number. Okay, so log base E is your natural number, and log 10. So I only had these two. I never had log base 3 of 10. I couldn't do that. Your calculators can do it now, but I couldn't. Okay? So, there you go. That's for today's lesson. Now, the only thing you got to be careful of is when you type in log of a decimal number, just make sure to be careful whether it's positive or negative. Okay, because if you do, for example, E, 0.4 to the power of x less than or equal to 0.3, your goal is to do this. You would say log both sides, log 0.4 of 0.4 to the power of x less than log 0.4 of 0.3. Okay? The issue here is that yes, whilst log 0.4 of 0.4 will cancel out, we can't say that this is true. Okay? Because if that is a negative number, then your signs switch. The reason why it switches is because if this is a negative number already, then when you divide both sides by a number that's negative, the signs have to switch. That's how it works within equations. Yeah, so every time you had like negative 2x is greater than or equal to 1, and you divide both sides by negative 2, you wouldn't say it's greater than or equal to negative half, but you would actually say that sign switches. Okay, so that's what we learned back in year 7, 8, 9 about equations, and that's the only thing you got to be careful of when you're doing log and you get a negative number. So just check if it's a negative number first. If it is, switch the signs. Okay, but that's 13F, and that's it. Now, if you haven't done 13E, I really want you to go back, learn your 5 logarithmic skills. Okay, when you add, you times them. When you subtract, you divide them. Anything, log of 1 will give you 0. Log of itself is 1, and your final rule was that you can bring the power up. Okay, the value up. So I need you to know your 5 rules to do exercise 13E. If your 13E is good, 13F should be fine. Then we can sketch. You can sketch. You can do the up, down, left, right, reflection in the X, reflection in the Y. All that's the same. And you got applications. That's it. So the hardest part of chapter 13, learn your logarithmic skills. Learn your exponential skills. Okay, so your algebra for your index laws, you had 8 of them, and your logarithmic rules, you've got 5 of them. So learn all of that. That's 13 in total. Okay, so really if you nail it down to a few exercises, it was only just 13D, 13E, and maybe a sketching or application. Right? So really 3 exercises that are really important for chapter 13. Work on that. Okay, but I'll pause the video here. I want you to either work on 13E or you're going to 13F, but E is what I'm seeing that most people are up to. Okay, or D or E. It's one